exponential functions and logarithms. So we're showing you those things, and then some people like, are you sure we actually need this? It sounds like a school material. So I decided to check some models which have them. Many models have exponential functions. It's not like I even looked hard. So the first one I found was mathematical model of the estimation of the car crash. And people have very good salaries by estimating how likely you say a male, 37 years old, with 2 kids will have a car crash. And based on this estimation, this is going to be your insurance price. Make sense? Or a female, 25, still a student, no kids. Interesting, will be different price, and so on. And statistics shows people with kids are more careful, less likely to have a car crash, and so on. So this is the estimation. What do you see here? Do you see this exponential? Oh yes, here it is. Here's exponential function. And that's why we need to teach you how to differentiate those things, how to work with them, how to combine them. So today we're going to differentiate exponential functions. This sign called a sum notation comes in calculus 2 class. Sine and sine, trigonometric functions, means some kind of escalation is happening, up, down, up, down. That's why we push trigonometrics so hard. Next week we're going to do trigonometric functions. Framework for mathematical modeling in soil tree system. Whatever it is, you have to read the article, whatever they mean, but I see exponential function here. Sometimes if exponential function has huge exponent, they put literally word exp and then huge exponent over there. You need to learn how to differentiate this, you know, like
all that's the exponent of
in the brackets. Everything in the brackets is exponent. Yeah. And then you see this guy, this u sub x is a canopy layer apparently of the exponential decay profile. Exponential function is there. How fast the decay happens? Find me derivative. So I need you to be able to differentiate those things. So in a week, basically. Now, the last one looks super scary, and that actually goes to calculus 3 class. This is a partial differentiation, calculus 3 class. This notation, calculus 3 class. Vector notation, calculus 3 class. And then I don't see any exponential, and then found it, z. So this z guy actually is a hidden exponent with a negative exponent here, means it's decaying. Something is decaying. And that's how in science you will be doing some internship with someone or research. You will say, oh, I see e to the minus something. Something is decreasing really fast. So some kind of exponential decay happens because e to the negative shrinks, right? So that's interesting. And that's how I wanted to show you there's so many studies, cancer cells, how microbiology works, space science. They all have exponential functions. We use logarithms and exponential functions in many models. So you have to be good at that. You have to be good at that. And that's why we're introducing the differentiation of log and exp. And I actually showed it before. Logarithm, if you differentiate log, it becomes 1 over x. If you differentiate e to the x, it's e to the x. But there is a logarithm with different base, not only natural one. So if you have an extra base step, base is not e, but a, then it's still going to be 1 over x. But then don't forget to divide by ln a. If you have a to the x versus e to the x, it's still going to copy itself, like e to the x copies itself e to the x. But then don't forget to multiply by ln of the base a. That's the difference. That's the difference. And now some fun examples. It becomes actually fun after this, up until we hit logarithmic differentiation. It's pretty fun. So what is, based on these formulas, ln 35 ln x prime, 35. Okay, you know 35 is multiplied, right? Then it means you have to keep it. So it's going to be 35. ln x gives you what? 1 over x. I just showed you formula number 1. 1 over x. So usually people just become fast in this and they see it's 35 over x. It's just less space. It takes less space if you write it like this. How come? Because 35 was a constant multiplied by the log. Log gives you 1 over x. Make sense? So the speed of the log is 1 over x. 1 over x in the future, I will explain you that 1 over x considers to be a slow function. Now it makes sense. Log is slow, 1 over x is slow, and they have connection. Derivative of log is 1 over x. What is derivative of ln of 35? Nope, it's not 1 over 35. Log of 35 is a constant, so it's 0. Just to make a funny joke about this, make sure you don't just use differentiation every time you see prime. You should be complicated formula. Maybe it's product rule. Log of 35 is some number. Derivative of the constant is 0. Because constant does not change. What's the speed of the constant? 0 speed. And now chain rule. Of course, we're going to go through chain rule at you from now on, quite a lot. So ln of 35x. First, I see log. Log tells me differentiate log. Whatever you have inside, 1 over that thing inside. So 1 over everything inside, 35x. Make sense? Log says 1 over everything inside. But now I'm looking inside based on the chain rule. So this is chain rule. Chain rule says I keep looking back over here and I see 35x. So I have to multiply by the derivative of the 35x. What is derivative of 35x? 35. And now doesn't it feel weird? You actually can cancel out 35 and 35 and it's still 1 over x. So after all, because of the chain rule, it doesn't matter. Derivative of log of 35x is the same as just derivative of ln x. They're slow, so the speed is the same. The speed is still 1 over x. Log of 7x prime still will be 1 over x, because 7 will simplify with 7 if you perform chain rule. But if you do it step by step, you will not make a mistake, so you don't have to memorize this. Now, more chain rule. Log of the polynomial. Always say to yourself, I see log, I'm differentiating log. It will be 1 over everything. Everything is pretty long, so I know it's going to be a long fraction. 1 over everything, 3x squared plus 5x minus 10. Chain rule says times derivative of the function inside. And now we're going to teach you how to take less space on the paper. Erase this one. And then put times piece on the top, because why not? You multiply anyway. So I'm multiplying by the derivative of the function inside. Derivative of the function inside is 6x plus 5. And this is the answer. Not too bad. You do it a couple of times, students actually usually like it. So the top part comes from the chain rule. 1 over everything and then times derivative of the function inside. Now, log with the base 5, that's supposed to trigger you that that's a special case. It's not just 1 over everything, then chain rule, but it's also a piece with a different base. Don't be afraid. The difference is 1 over everything, and then don't forget to divide by the log of the base. Since base is 5, it will be a log of 5. Let's do it. 1 over everything. I see x squared plus 5. Then the formula says when you divide it by everything, don't forget to also divide by the ln of the base, natural log of the base. So I'm like, okay, it should be natural log of the base. Base is 5, so it's going to be 5. Am I done? How do I know I'm not done? Exactly, still x squared plus 5. It's supposed to trigger you. Wait, I never differentiated that piece. Probably I'm doing wrong, right? So not wrong, but you're not done. So I would erase the top to save some space, and now it says, now the chain rule says, take the derivative of the function inside, which is 2x. Good job. Not too bad. Not too bad. Those guys are not too bad. You practice more and you do better. Exponential functions. Exponential functions. Example 1. Same idea, but it's actually even more fun. What is 13 e to the x? If derivative of e to the x is e to the x. It's still 13 e to the x. Exponential function is so fast. And when you ask a question, how fast is e to the x? The answer is e to the x fast. Then, what if I will give you e to the 13x? What's the difference? Now it's chain rule. E to whatever tells you to copy the whole thing. E to the 13x is e to the 13x. That's the idea of exponential function. It says, just copy me. I'm fine with that. But then you look inside. You look inside of the exponent. Chain rule tells you to do it. Because I never differentiated 13x. Chain rule says, don't stop. look at the exponent and don't forget to multiply by the derivative of the exponent, which is 13. So this is chain rule. Does this make sense? So e to the x is e to the x, but e to the sine x, that's chain rule. E to the 5x, that's chain rule. E to the minus pi x, that's chain rule. How about e to the 75 derivative?
0.
Did you guys get it? 0? Good. It's a number. 2.7 something something raised to the 75, so it's multiplied by itself 75 times. Not too bad. Okay, good. Because constant. How about 1 over e to the 35x prime? On this quiz I just gave you, did you do quotient rule or you did chain rule? Chain rule is faster. If you see 1 over something, I would not recommend to do quotient rule. The answer will be the same, but it's just better to rewrite it as what? Negative 35x. Good job. And now the rule is still the same. You see exponential function with base e, copy it. So I'm copying the whole thing. Now chain rule steps in and says, well, don't stop. Look inside of the exponent and multiply by the derivative of that piece, which is negative 35. So you see, e to the negative exponent means some kind of exponential decay times the negative rate. So it is negatively decreasing. The last one, last minute, last example. 6e x times cosine x. This is interesting. Exponential, so first I have constant in front, then exponential function, then the product rule with trigonometric function inside. Doesn't matter, I see e, I copy it. X times cosine x. You see? Copy. So this piece always copy because I see e to the something. Then it says, look inside of the exponent and differentiate that piece. Derivative of x times cosine x, hopefully you remember, it's a product rule. Product rule says, product rule. Differentiate x, that's 1. Copy cosine, plus, copy x, differentiate cosine, minus or plus? Minus, remember, it's going to be negative sine x. You can simplify this or keep it as it is. So chain rule told you that there is a product rule in the exponent of the exponential function. But still, when you work with e to the something, it's always copy first. Copy first, then dive inside, and whatever is inside, you work with that.